Well, we got 5-4 solving radical equations. Welcome to another boring math video. Here's your benchmark results. In Dresden High School, our provision advanced was 52% versus everyone else in the county at 29. So we obviously look better than the county, but I am accustomed to a number closer to 70%. So do better. All right, so anyways, goal of this section is solving radical equations. So solve square root of x plus 5 minus 1 is equals 3. And your general idea here is to isolate the radical or the exponential and then counteract the root or the power and then profit because you're done. So anyways, we're going to add 1 to both sides. We're just playing the isolation game. If we add 1 to both sides, we have 4. Unless you've been living under a rock, the opposite of a square root's a square. And if we square a square root, because that understood too, those two things cancel. That gives us x plus 5 equals 16. If we subtract 5, we have 11. Now, it says even roots sometimes have extraneous answers. And we didn't take an even root, we fixed an even root. But, does this work? Well, let's plug it in. We're going to let that x be 11. 11 plus 5 is 16, and the square root of 16 is 4. But if we take away that 1, I probably should have wrote that, all of it. Forgive me, it's early in the morning. This is supposed to equal 3, right? If we go back to the original equation, this is root 16 minus 1. Does it equal 3? Well, 4 minus 1 is 3, so 3 is equal to 3. It passes the test. You do need to be checking things. All right, another one of these, solve a radical. It's supposed to be a try it for y'all, but this is a video. The opposite of cube rooting is cubing. That'll give us x minus 1 equals 8, and we're just going to add 1 and get 9. Odd roots don't have extraneous answers. Forgive me. Moving forward. The speed, v, of a vehicle in relationship to its stopping distance, d, is represented by the equation v equals 3.57 square roots of d. What is the equation for the stopping distance in terms of the vehicle's speed? That means you're going to solve this thing for d. So if I'm going to solve this thing for d, I'm going to have to do some opposite actions. First thing I need to do is the easy thing to do, which is divide both sides by 3.57. Okay? There's really not anything you can do with that. It's just v over 3.57. But that's equal to the square root of d. Now, the opposite of a square root, again, unless you've been living under a rock, is to square, because that annihilates the understood 2. And this gives me v squared over 3.57 squared being equal to d. And we don't need to push buttons. We don't need to know what 3.57 squared is. We just round the thing anyways. So that's done. Now, what is the relationship between the original equation and the one you wrote? Well, what they have done is they have swapped input and output. Notice this one had an input of distance. This one had an input of velocity. So they have swapped input, which we call domain or x, right? And output, which we call range or y. Things that do that are called inverse. So this is an inverse. Introducing that word today because in a couple of days we're talking about inverses. Moving forward with our lives, identify an extraneous solution. So evidently this equation has an extraneous solution. So we have a radical equation, square root of 3x minus 2 equals x minus 4. And what we're going to do is we're going to fix that square root by squaring. Okay? Now, do not think that x minus 4 squared is x squared plus 16. You failed my course. You will fail. Plain and simple. If you're going to square something, you write that bad boy twice. Now, when we square the square root, the 2's cancel, frees up 3x minus 2. And the right-hand side, we got to write x minus 4 down twice. And I'm going to FOIL. I'm going to have an x squared minus a 4x minus a 4x plus a 16 because I know how to multiply. combining my like terms on the right-hand side, I'll have x squared minus 8x plus 16. I see this, I think quadratic, right? It's got an x squared. I set equal to 0 so that I can do one of three things. I could use a zero product property if it factors. I can do the quadratic formula. If I'm feeling frisky, I can complete the square. All right? Lots of choices. But anyways, I'm going to put a 0 on the left-hand side. Negative 8x minus 3x is minus 11x. 16 plus 2 is 18. And by golly gee, wow, that thing will factor. Factors of 18 are 9 and 2. If they're both negative, you add to negative 11. Kick in the ZPP. If you don't know what ZPP is, you ain't been paying no attention. 0 is x minus 9, or 0 is x minus 2. So x is 9, or x is 2. Wow, that was easy. Now, let's check these answers, okay? We're going to take our 9, and we're going to plug it in the original equation. The square root of 3 times 9 minus 2 is supposed to equal to be 9 minus 4. Like it's supposed to be true, right? So 3 times 9 is 27. You take away 2, you get 25. Square root of 25 is 5. And 9 minus 4 is also 5. So hey, that checked. This is definitely what we call a good answer. It's a real answer. Now let's plug in the 2. The root of 3 times 2 minus 2, take away 2, is supposed to be equal to 2 minus 4. Well, this gives me a negative 2. And when I do the math over here, 3 times 2 is 6. Take away 2, this is root 4. I don't know why I have an extra 2 there. Too many 2's. Got a little too happy there. And the square root of 4, if you're not solving for x, is just 2. Fails. This little guy right here is extraneous. The definition for extraneous down here is a solution of an equation derived from original equation, but is not a solution of the original equation. So, know how to find an extraneous solution. Never try it. Solve each radical, identify any extraneous solutions, and you're going to isolate the radical first. So that's going to give you the root of x plus 14 equals x plus 2. The opposite of a square root is a square. If you're going to square x plus 2, you're going to have to write it twice. If you don't write it twice, you have already failed my class. You just don't even know it. X plus 2 times x plus 2 is x squared plus 4x plus 4. Left-hand side still x plus 14. Set it equal to 0, so hopefully you can use a zero product property. 4x minus x is 3x. 4 minus 14 is negative 10. Will that factor? You bet you will. To take a 10, you're going to need a 5 and a 2. The 5 is positive, the 2 is negative. Hitting it with BP, x is negative 5 or x is 2. Which one's real, which one's not? I don't think I took a single breath as I worked out that entire problem. So if x is negative 5, this is going to say the square root of 9 minus 2, and we're letting x be negative 5, equals negative 5. That's going to be what? Plug in a 5, right? That's going to be 1 equals negative 5. That is obviously extraneous. It did not work. If x is 2, you're going to have the square root of 16, because 2 plus 4 is 16, take away 2 being equal to 2. That's 4 minus 2 being equal to 2, which is true. So real, extra. The main thing in extraneous is just the extra part. It is an extra answer. It's just not right. All right, what are the solutions of this bad boy? X squared plus 5x plus 5 to the 5 halves is 1. Off to the side, I have a little note. The opposite or inverse of any power is its reciprocal. The examples are reciprocals. The reciprocal of 2/3 is 3 halves. The reciprocal of negative 1/4 is negative 4. The reciprocal of 3 is 1/3. You flip the number. That's all you do. You don't change signs. You just flip the frickin' number. This is not perpendicular slope from geometry in Algebra 1 in 8th grade. So anywho, what are the solutions to this equation? Well, what we're going to do is we're going to raise both sides to the reciprocal. And the reciprocal of 5 halves has always been 2/5, and it always will be. Now, that's going to free up x squared plus 5x plus 5, and I know that some of you guys are just confused as can be about notation, but 1 to the 2/5 is saying, think about your p over r notation, the 5th root of 1 squared. 1 squared still be 1, and the fifth root of 1 is 1. Wasn't such a bad problem after all. Next move, subtract 1 from both sides. Next move, attempt to factor. Takes an x and x to create x squared. Factors of 4, 4, and 1. And if you take a positive 4 and a positive 1 and add them together, you get 5. So by ZPP, x is -4 or x is -1. Check your answers. A -4 squared is 16. 16 plus 5 is 21. 5 times -4 is -20. 21 minus 20 is 1. 1 is equal to 1. Let x be -1. A -1 squared is 1. 5 times a -1 is -5. 1 minus 5 is -4. Add 5, you get 1. They both work. Easy peasy lemon squeezy. 2 to go. Then I got to do your homework. What is the solution to x plus 18 raised to 3/2 being equal to x minus 2 cubed? All right, so the funnier looking exponent is where I would start this one off. So what I'm going to do is I'm going to raise both sides to the reciprocal of 3/2, which is 2/3. Now let's think about this one. This is 3 times 2 over 3. 3's cancel. This makes the right hand say x minus 2 squared. Left hand side is now x plus 18. But wait, there's more, because you still got to square x minus 2. So let's square x minus 2. We're going to write it twice like we should. Anything else would be wrong. X squared minus 4x plus 4, when you square it, still equal to x plus 18. We're going to set it equal to 0 and use ZPP. -4x minus x is minus 5x. 4 minus 18 is -14. Will that factor? Yes, it will. It takes a 7 and a 2 to make a 14. And I need a -7 and +2 to add to the -5 in the middle. I'm going too fast for you. Just slow that video on down, kids. By using the zero product property and imagining in my mind that x minus 7 was 0 or x plus 2 was a 0, x is either 7 or x is -2. Do they work? Well, let's find out. I don't think, actually they might. So let's see here. We have x plus 18. That's -2 plus 18 to the 3/2, which is going to be the square root cubed. It's going to be the square root of 16, which is 4. 4 cubed is 64. Now, on the right-hand side, I was letting x be -2. I'd have -2 minus 2 cubed, which is, again, -4 cubed, which is 64. So -2 works. Plug in a 7. 7 plus 18, again, we're taking the square root and then we cube it, should be equal to 7 minus 2 cubed. 7 minus 2 cubed is 5. 5 cubed is 125. Over here, what we have is we have 7 plus 18, which is 25. Square root of 25 is 5, and 5 cubed is 5 cubed. Both good. All right, solve the radical equation with 2 radicals. This is the last one in the notes. By golly, thank you. I'm done with it. What you're going to do is you're going to isolate a radical. It doesn't matter which one you isolate, but I'm going to isolate the root of x plus 9. Right-hand side would be 3 plus root 2x, or root 2x plus 3. It's up to you. The opposite of a square root is a square, and you don't get to just square both pieces. The reasons kids do that is because they don't memorize their exponential rules as they should. You have to write it twice, and it'll be a little harder to FOIL out. But 3 times 3 is 9. 3 times a root of 2x is going to be plus 3 roots of 2x. Again, you do it in the middle. Plus 3 roots of 2x. And then a root of 2x times root of 2x is 2x. So, let's see here. The 9's cancel. Gives me an x equals, looks like I got 6 roots of 2x plus a 2x. We're going to shift that 2x over. X minus 2x is -x, and that would be equal to 6 square roots of 2x. Not done yet. Just making sure I didn't make any mistakes real quick. I haven't. So another radical has shown up. So what we're going to do is we're going to isolate it. -x over 6 is the square root of twice x. The opposite of a square root is a square. If you square a -x, you get x squared. You square 6, you get 36. X squared over 36 is twice x. Good stuff. Would have actually made sense not to divide that 6 out. In fact, let's go back and do that. I thought about not doing it. You don't always have to isolate the radical. Sometimes it makes sense not to do it. So 6 squared is 36. 2x, the root of 2x squared is going to be 2x. And the left-hand side is going to be x squared. So what we have here is we have that x squared is equal to 72x. We're going to set it equal to 0. And then we're going to factor, and this one does factor. It's x times x minus 72 equals 0. And then we're going to use ZPP. X is 0, or x minus 72 is 0. So x would be 72. There you go. Now the real thing is here is, does it work? All right, so if we plug a 0 in, 0 plus 9 is 9. The square root of 9 is 3. There's a 3 here. This becomes 0. 3 is 3. We plug a 72 in. 72 plus 9 is 81. The square root of 81 is 9. Minus. Here we have the root of 144. That's 9 minus 12 is negative 3. They don't work. Extra. Extraneous. All right, so there was 5-4. I hope you enjoyed that exciting, fast-paced, boring math video. Good day.